I try and emphasize it when I teach it, but it's been a while and maybe I didn't teach you or maybe you missed this part. But basically in relative motion, we describe it as there being two different types of problems. There's the type of question where the plane or the boat or whatever it is gets pushed off course. That might not be the best description, but that's how I'm going to describe it. And then there's the other kind of question. It could be a plane or a boat or a swimmer where they seem to know that there's a current and they correct or adjust for the current or wind. To emphasize how these are different, I'm going to show you the subscripts for the equation that we can do for vector addition, and I'll outline the differences that way. You don't have to do these by equation, just to show the difference, I want to highlight the equation. Let's talk about a plane flying through the air. We could say that the velocity of the plane with respect to the ground is the velocity of the plane with respect to the air plus the velocity of the air with respect to the ground. It's almost as if these middle subscripts cancel out. So the A's cancel out. To get from plane to ground, we go plane to air plus air to ground. Oops. If the plane is pushed off the course, so in that first style of question, generally speaking, we know both parts of the plane's velocity through the air. We know the number, we know how fast it's going, and we know the direction. We also know both things about the air relative to the ground. We know the number, the value of it, and we know its direction. But we don't know anything about the plane's velocity relative to the ground. We don't know the number for how fast it's going, and we don't know the direction. Basically, there's two parts to a velocity, the number and the direction. In our vector equation, we can handle two unknowns. In this first style of question where the plane is pushed off course, or it just points its nose straight west and the wind pushes it north off of that, in that style of question, our two unknowns are on the same side of the equal sign. We don't know the value of the resulting velocity, and we don't know the direction of the resulting velocity. In grade 11, we did a lot of rectangular questions, meaning just plain old Pythagorean theorem, and SOHCAHTOA was enough to solve it. I'm going to rewrite that out, and I'll talk you through the other style of question. Oops. The velocity of the plane relative to the ground is still the velocity of the plane through the air plus the velocity of the air over the ground. I think Mr. Zaire did a slightly different form with the subscripts, but the same basic idea. P and G for plane to ground, P and A is plane to air, A and G is air to ground. In the second style of question where the pilot knows that there's a wind and adjusts for it or accounts for the wind, whatever wording you want to use, in that kind of question, we know how fast the plane is flying through the air, but we don't know what exact direction the plane is flying to adjust for the wind. We do know everything about the wind. We know the number and we know the direction. With respect to the plane flying over the ground, that velocity, we don't know how fast it's going, but in the wording of the question, you'll be told what direction we want it to fly. So it might say a plane is chartered to fly straight south. We know that at the resulting velocity, the plane relative to the ground, we're told its direction in the question. What makes this style where the plane knows or corrects about the wind, what makes it a little bit trickier, a little bit weirder, is notice that our two unknowns are now split up. One of them is the speed portion of the velocity relative to the ground. We don't know how fast it's moving over the ground relative to the ground, but we know which way it's going relative to the ground. The other unknown is in the velocity of the plane through the air. We know how quickly it's moving through the air. We just don't know what exact direction it's moving through the air to get it to that requested or chartered velocity relative to the ground. Since the unknowns are split up, we don't know the exact shape of our triangle. So we'll do a couple, I'll solve one out again. But basically, I kind of take a guess at which way I think the plane is going through the air. It's got to angle into the wind to fight the wind. So I'm just going to sort of make a rough triangle. knowing how long the side is for the plane relative to the air, take a kind of educated guess at which direction it's going to build the triangle, and then use my math skills to solve the triangle. But the bottom line is there are two different kinds of relative motion problems. If we think about it in terms of an airplane, here's the two equations and how they're different. In the one type, both unknowns are on the same side of the equal sign. In the other type, the unknowns are separated. One, the direction of the plane, we don't know what its direction through the air is, and relative to the ground, we don't know how fast it's actually moving.